Welcome back to the deep dive. Today we're moving way beyond those basic power strips you see everywhere. We're going to get into some really serious high-level electrical protection, and we're going to use the SurgeX SA-82 FlatPak Surge Eliminator as our main example. Our mission is to really understand the engineering that protects super sensitive AV gear. We're talking about 4K projectors, high-end displays, especially when space is tight.
Right, in those custom installs where everything needs to be hidden. And this whole conversation, it really revolves around one core innovation. It's called series mode technology. And for anyone who's serious about clean power, this is where you can really see the difference between, let's say, basic protection and guaranteed elimination.
Okay, so let's start there. What makes series mode so different from a regular surge protector?
The big differentiator is how it handles all that excess energy. Your traditional, inexpensive surge protector uses what we call sacrificial parts.
Sacrificial meaning they wear out.
They wear out, exactly. And their job is to see the surge and then shunt it, basically, divert it away.
And they usually send it straight to the ground wire.
That's the move. They just dump all that nasty energy right onto the ground line.
Hold on, I thought the ground wire was the safe path. Why is dumping a huge surge there a problem for my expensive audio gear? I mean, isn't that how protection works?
That is the absolute core of the problem. When you throw a massive spike onto the ground line, you create what's called ground contamination.
Ground contamination.
Or common mode disturbances, as engineers would call it. Think of it like this. Your sensitive gear uses that ground as a clean 0-volt reference point, and you just contaminated it. Our source material is really clear on this. It leads directly to things you can see and hear, hissing sounds, pixelation on your screen, humming.
Ah, so the protection is actually polluting the very system it's supposed to be protecting. That makes perfect sense. So series mode just avoids that entirely.
It completely flips the script. Yeah. Instead of diversion, the goal is elimination.
So that not shunting to ground at all.
Not at all.
Yeah.
You totally avoid those common mode issues, which preserves the signal integrity. And on top of that, the design is 100% fail-safe. It's non-sacrificial.
Meaning it doesn't wear out? It can take hits over and over?
And perform exactly the same every single time.
That's a huge deal. And the numbers here, they really back that up. The specs say it eliminates surge energy up to 6,000 volts and 3,000 amps. But the spec that just blew me away was the surge let-through voltage. You hit it with a 6,000 volt surge, and the let-through is 0. Not a single volt gets through.
0. That's absolute protection.
For any device up to its load rating, which is 8 amps at 120 volts.
Yeah.
But how do you fit that kind of, that's heavy-duty engineering. How do you pack that into a small unit?
And that's where the FlatPak design comes in. It's built for those tight spaces. It's super compact, weighs just over 3 pounds. And the enclosure itself is made of magnetic shielding steel. That's critical when you're mounting this thing right next to, say, a media player. You don't want any interference.
And it seems like they've layered some intelligence on top of the raw protection, too. I saw the standard SA-82 is for, non-network devices, but there's another version, the SA-82AR, that's access-ready, which has remote IP control.
Yeah, that's a game changer for installers. A technician can log in remotely and power cycle just one outlet, set up schedules, or use a feature called auto ping to reboot a frozen device. The protector becomes a management tool.
That's really smart.
And we can't forget about the constant everyday noise. It's not just about the big catastrophic spikes. This unit has overvoltage shutdown, which kicks in at 145 volts and then resets itself. But crucially, it also has impedance tolerancing, EMI-R5 filtering.
Okay, so that's for cleaning up the background static on the line.
Exactly. And it is aggressive filtering. We're talking about 56 decibels of noise reduction at 300 kilohertz. It's constantly cleaning up that line noise that slowly degrades performance.
So if we had boil it all down, what's the one key takeaway for our listeners?
It's simple, really. You are moving from a strategy of power diversion, where you hope the bad energy goes somewhere safe, to a strategy of guaranteed power elimination. It's non-sacrificial, and it actively preserves the quality of the signal your gear is trying to process. It's about performance as much as it is about protection.
And that leads us to a final thought for you to chew on. We just talked about that aggressive EMI-R5 filtering needed to clean up the constant electrical static. So given how much that minor ongoing noise can silently degrade our expensive digital electronics, how much more attention should we be paying to the filtering specs of all the power sources in our lives, not just the ones protecting us from a sudden catastrophic spike? Think about that ongoing electrical hygiene. We'll see you next time.